Hello everyone. Today I am going to show you this systematic analysis of an unknown salt. First, you write the aim of the experiment. Determination of anion and cation of a salt. So this is our aim of the experiment. Then you write physical observations. In physical observations, there are 3 steps. Number 1 is color. So this is our unknown salt. What is the color of the salt? So this is blue in color. So simply here you write blue. Number 2 is physical state. So if your salt has definite geometrical shape, then you write crystalline, and if your salt looks like talcum powder, then you simply write amorphous. So today's in our salt, this is crystalline salt. Here you write crystalline. Number 3, solubility. For the solubility test, you take a test tube, then you take a pinch of salt. Now I have added water, then you try to dissolve it. If it completely dissolves in cold water, then you write, now you see it is completely dissolved in cold water. So here I can write soluble in water. So our physical observation is completed. Now we have to do the dry test for anion. Anion is also called acid radical, and it is negatively charged. The negatively charged ions are called anions, and the positively charged ions are called cations or basic radical. Now you give a heading, dry test for anion. So this is the heading. Then you draw a table, experiment, observation and inference. So this is our table. In the dry test for anion, there are 2 experiments. One is dilute sulfuric acid test and other is concentrated sulfuric acid test. So this is dry test. So you have to take dry salt, no need to use salt solution. So our first experiment is salt plus dilute H2SO4. Let's try. What happens? I have taken a dry test tube and I have taken some salts here. So our first reagent is dilute sulfuric acid. This is dilute sulfuric acid. Here you put very less amount of dilute sulfuric acid, this much sufficient. So there is no observation. After adding now see, this is dilute sulfuric acid test. Here I have taken salt, then added dilute H2SO4. After adding dilute sulfuric acid, if you observe effervescence, then it indicates carbonate radical CO3 to negative. If you observe smell of rotten egg, then it indicates sulfide ions. If you observe brown gases, then it indicates nitrite, NO2 negative. So there is no observation in dilute sulfuric acid. So simply here you write this is the experiment, observation and inference. This is observation and this is inference. Salt plus dilute H2SO4. So simply here you write no observation, no obs. In inference means all the radicals in dilute sulfuric acid groups are absent. Here you write carbonate, sulfide, nitrite are absent. So our dilute sulfuric acid test completed. If you observe nothing in dilute sulfuric acid test, then you have to proceed for the next step, which is concentrated sulfuric acid test. Please wait for a minute, I have to bring a soft pencil. So our dilute sulfuric acid test completed. Now number 2 test is concentrated sulfuric acid test. Here you write salt plus concentrated H2SO4. Let's try what happens. Again you take another test tube, put some salt here. This is concentrated sulfuric acid. Now added concentrated sulfuric acid. This is sufficient. At room temperature, there is no observation. At room temperature, if there is no observation, then we have to do one thing. We have to add a piece of copper turning here, then you heat the sample in Bunsen burner. So this is our, wait for a minute. So I have applied heat here after adding copper turnings. So there is no observation. After heating, if you observe reddish brown fumes, then it indicates nitrate radical. So again, there is no observation. You throw the sample. Now see, the concentrated sulfuric acid test is for 4 radicals. At room temperature, after adding concentrated sulfuric acid, if you observe pungent fumes, then it indicates chloride. If you observe brown fumes, then it indicates bromide. If you observe violet fumes, then it indicates iodide. Since there is no observation at room temperature, so I added copper turnings, then I applied heat. After heating with copper turnings, if you observe reddish brown fumes, only then it indicates nitrate, NO3 negative. So again, after heating there is no observation. Here you simply write no observation, and in inference, chloride, bromide, iodide and nitrate are absent. So our dry test has been completed. So here we have noticed that in dilute sulfuric acid test and also in concentrated sulfuric acid test there is no observation. If you observe nothing in both the cases, then it indicates the independent radical, and sulfate ion is called independent radical. So now we will do weight test or conformity test for sulfate radical. So you give a heading, weight test for anion, or within bracket you write confirmatory test for sulfate radical CuSO4 2 negative. So this is the heading of our experiment. Again you write here experiment, observation and inference. In the experiment box you write this is with this means we need to prepare salt solution. Here you write salt solution plus BaCl2 solution. So we have to perform this barium chloride test. We need to prepare here salt solution. Take salt, then you put water. Then dissolve the sample. This is our salt solution. The main reagent is barium chloride. Simply you add here barium chloride. So after adding barium chloride, some observation coming here. So this is white precipitate. This is not transparent solution. This is precipitate. Here we have to write white PPT. If the precipitate dissolves in dilute nitric acid, then it is the carbonate, and if the precipitate insoluble in nitric acid, then it is the confirmatory test for sulfate. Here you put dilute nitric acid. If precipitate dissolves, then carbonate. If precipitate not dissolves, then sulfate. So after adding dilute nitric acid, there is no sense. The precipitate is insoluble in dilute nitric acid. White PPT, simply you write insoluble. Insoluble in dilute HNO3. So this is the observation for sulfate radical. Here SO4 2 negative present. Now you see all weight tests are called confirmatory tests. So here you can write also sulfate confirmed, and all dry tests are preliminary tests. So our determination of acid radical is completed. Now we have to determine the cation, means basic radical. So basic radicals are divided in some groups. So the weight test for basic radical is also called group analysis. It's group analysis. You can write weight test for cation. So this is our heading. Basic radicals are divided in some groups from 0 to group 6. So if your salt is colorless, then you start from 0 group. If your salt is colored, then you need to start from group 1. So since our salt is colored, so I am going to start from group 1. Again, you write here experiment, observation and inference. In experiment box, the number 1 test is salt solution plus dilute HCl. This is the test for group 1. So I have prepared salt solution, then you put dilute HCl, so this is dilute HCl. So no PPT, no observation. Here you write no PPT, means precipitate, means group 1 absent. In group 1, lead ion is present. So lead ion is absent. Since there is no PPT, means group 1 absent. Lead ions is absent. Now the test for group 2. For group 2, you take this above solution. Here you write above solution. Above solutions means group 1 solution. You do not throw the sample. Above solution plus heat plus H2S, hydrogen sulfide gas. So this is the above solution. You heat the sample, you heat the solution, no need to boil, just heat the sample. Then you pass H2S gas. This is Gibbs apparatus. From Gibbs apparatus we get H2S. Here you pass. So I passed here H2S gas. So this is the black colored precipitate. Here you write black PPT. Black PPT means group 2. Group 2 is present. In group 2, copper and lead ions are included. If your salt is blue in color, then it indicates copper. If your salt is colorless, then it indicates lead. So our group analysis is completed. Now we have to do precipitate analysis. We have to analyze the precipitate. Since in one group there may be many radicals, so we have to identify the correct one. Only one radical will be present in a salt, means one anion and one cation. So our group analysis is complete. In group analysis, we identified that group 2 is present. Now we have to perform precipitate analysis of group 2. This is PPT analysis of group 2. For precipitate analysis, you take the black precipitate. No need to take the solutions. You can also filter it. So this is the black precipitate. I have decanted of the liquid. This is black precipitate. You dissolve the black precipitate in minimum quantity of 50% nitric acid. This is concentrated nitric acid. It is 100%. We need to prepare 50%. So this is 100% nitric acid. You take another testing. Take same amount of water. So I need to prepare 50% nitric acid. You slowly add here same amount of water. Now it is 50% nitric acid. You put here minimum amount of 50% nitric acid, a little bit, okay, this much sufficient. Then you boil the sample. Precipitate is not dissolving. Add more. Now dissolved. It is dissolved. It is dissolved. So after boiling, this precipitate is dissolved, almost dissolved. Now here you put ammonium hydroxide. This is ammonium hydroxide. After adding ammonium hydroxide, if you observe deep blue coloration, then it indicates copper ion. To the deep blue colored solution, you add here acetic acid and potassium ferrocyanide solution. So this is acetic acid. Here you put acetic acid. Okay. So this is potassium ferrocyanide solution. This is the confirmatory test for copper ion. After adding potassium ferrocyanide, if you observed chocolate brown PPT, only then copper is confirmed. So you see here, this is the chocolate brown PPT, and it confirms that our basic radical is copper. Here you can write black PPT. Black PPT is dissolved in 50%, dissolved in minimum amount of 50% nitric acid and boiled. To the above solution, added ammonium hydroxide. Then you observe blue coloration, and it indicates copper. Clear? To the blue color, solution, we added acetic acid and potassium ferrocyanide solution. Then we observe brown PPT or chocolate brown PPT. So it is the confirmatory test for copper, Cu2+. Clear? So our precipitate analysis is completed. Can you write the result? Our acid radical, radical is sulfate and basic radical is copper, Cu2+. Hence our unknown salt is copper sulfate, CuSO4. So this is the systematic analysis of an unknown salt. Thank you.